Hi everyone, welcome to this course of Semiconductor Process and Device Modeling. I'm taking this course for the third time, and this time we have slightly modified based on my past experiences. So I think it will be a much smoother ride for you all guys. Okay, so before we start the course, I want to introduce myself. So let me introduce myself first. So, yeah, about me, I did my PhD in optoelectronics, focusing on silicon-based solar cells. Okay, so during my PhD, we had a collaboration with PV Labs, EPFL Switzerland, and also with Technical University of Denmark. So the idea of the collaboration is I do the simulations here in Centaurus TCAD, which you're going to learn in this course, Centaurus TCAD simulations. So these are terminologies you should keep in mind. So I did the simulations of the solar cells in Centaurus TCAD, and the fabrication is done in PV Lab, EPFL, and Technical University of Denmark. Okay, so fabrication in Europe, simulation in India. Okay, because we had the simulation facilities at that time, we don't have the fabrication capability of photovoltaics. Right now, we have some facility in Sasra as well to do some fabrication. We are also trying on that. We'll come to that. Okay, so that's the idea of the collaboration. So simulations, what the simulations do, why they depend on us is the simulations help them to understand how their device works. Okay, so you have to remember this as well to understand how the device works. So you do simulations. Okay, and also help them to improve their devices. So you got some performance metrics and you want to improve it. So simulations helps you. Of course, experiment they can try, but experiments are very costly alternative you have. So that's why people go for simulations. And they are very fast as well. Okay. During my PhD, I've also worked as a CSIR Senior Research Fellow, where I worked on characterization of these devices. So what do you mean by characterization is you would have studied the IV characteristics. What do you mean by IV characteristics? To study how the device behave when you apply an external stress, right? That is your that's the characteristics we know, right? IV characteristics. So IV characteristics of PN junction diode should be exponential. Okay, so you all know this in your basic electronics courses, right? So this is a slightly advanced characterization which help us. So IV characterization tells you whether device is working properly or not. Is there any series? Or we can learn certain aspect of the device. It has some series resistance. What about the resistive aspect of the device? We can learn from the IV characteristics. But if you want to dig even deeper, we have to go for other characterization techniques. Something we illuminate and we do. Something we measure the capacitance of the device and we measure. So uh, one of the batches they study CV characterizations, right? Where from that they can able to find the built-in voltage. So built-in voltage you can't measure directly. Of course, you can also measure from the IV. The other way to measure it using CV, capacitance and voltage characteristics. So you apply the voltage, you measure the capacitance. So end of the day, what we are doing is we are studying how the device behave. That's what it's called characteristics because it's the character of the device under the different stress conditions. Okay. So very similar analogies ourselves, right? So the real character of the person knows when we are in the real stress, right? So something similar to that. And also I did work on something called Agri PV. Anyone from the word can able to guess what is Agri PV means? Agri and PV, agriculture and photovoltaics in the same land. So you can see the crops are growing and also photovoltaic panels which are transparent. They are not glasses. They are photovoltaic panels on the roof of the land. So you will be extracting the energy as well as food in the same land. Okay, so that's Agri PV. So I also did some modeling of that. Okay, so these are about simulations and modeling so far. And I also worked as a Bhaskara Advanced Solar Energy intern at Purdue, just sponsored by our government at Professor Alam's lab. Okay, for 6 months. So that I focus on kilometer size forms, how to model them. Okay, so I told you now two terminology which is very useful for the course. One is model, simulation, characteristics, not two, three words. Okay. So modeling and simulation, that is the one which you're going to be clarified after the self intro. Okay, so don't worry about that. Yes, they sound similar, but they are not so. Okay, there is a small difference in them. We will be seeing at it in detail. Okay, so this is myself. You can see standing in the back row at Chicago conference on photovoltaics. Okay, this is my professor Alan. Okay, on the other side. Okay, so after my PhD, I got opportunity to join as a project officer in ORC Lab. It's one of the National Center of Excellence in IIT Madras. So there we focus on organic LEDs, organic photovoltaics mainly. So you can see myself here standing the facility to fabricate these wallets. So this is a machine which do the actual process, and this is the human machine interface. So myself I'm handling. So nearby is my colleague, Mr. Mani. So this interface is called human machine interface. Hope you understand what it means. It's an interface between myself, the human, and the machine. So whatever the instructions to the machine, you give it through this electronic panels. Okay. So it's just a very simple fabrication technology that just we heat them, evaporate them, and make them deposit. Okay. So that's how it works. It's called thermal evaporation. So we also learn how to make devices in this course. The first unit is about how to make devices. Okay. So thermal evaporation is one way to make them. So that's what we are doing there. We were doing there at the time. Um, then I also worked on organic PV, both the simulation as well as the fabrication. So right now, I'll show you. I have fabricated some organic PV. The same lab. It's also funded by our government. Okay, and also work on recently. I'm working on organic transistors in collaboration with Bosco sir, where we have the photolithography, all the facilities. So photolithography is another terminology you should remember because you will be using them in our course in the simulations and all. Okay, so these are the ways to pattern your devices. Okay, so you have planar, you want to make it like a sawtooth or something. You want to pattern your device, then we will use photolithography. Anyway, we'll be discussing, don't worry about that. uh, so using them we can do organic transistors. So I'm doing simulations as well as fabrication of organic transistors in our Sastra University. So if some are interested, you can even join our group. But because the experimental facility is limited, so the number of students for the experiment facility is limited right now. Then I worked as assistant professor at Amrita, and then I joined here at Sastra. So these are my area of interest: semiconductor devices and circuits and photovoltaics. So I told you, right, if I was fabricating these organic PVs, so these are them. Right? This is called mini modules, not cell. It's mini module. You can see I'm holding it in my entire hand. Um, so this is recently fabricated only last month. Uh, Luckily, we got some good module because for the past 2 years we have been struggling. But with God's grace, we're able to get some good progress in it. We'll come to it. Some of your friends also helping me in simulation of them. Okay, last year, one device morning student also helping me. So this is the same module. If you put it in the microscope, and you can see very tiny features of them. You can see different layers, but it's a 2D view. I'm not sure you're able to visualize it. It's a top view. Actually, it's a stack, but in the top view, it's all planar, right? So you can't see the stack, but you can see different layers. And then this is the IV characteristics, which I'm very much interested because this is what you're going to study in third and fourth, how the device works. So two things, just you can split the course into two things: how to make the device, how the device works. So by that, you make the device, you see how it works. So you have a complete understanding of the device level thing in this course. Okay. So anyone able to see what is this trend is? It's exponential. I told you, right? Any diode will have this trend. Photovoltaics, photodiodes, photodetectors, all LEDs, all are diodes. So they will have IV characteristics which are exponential. There'll be small shifting here and there, you would have studied time shifting, right? It is your old current shifting or voltage shifting, but the trend is exponential because they are all diodes. Okay, so these are some of our, sorry for the background noise. So these are our some of our papers along with your seniors. Okay, so we have submitted and got